Good afternoon, everyone. My name is Megha Iyer, Associate Editor of EPR magazine, and I welcome you all for an interactive power talk on next generation power substations. Power substations are critical components of the power and grid infrastructure in India, and several aspects for their designs, operations, and maintenance have been the subject of discussion and debate. One of the key areas is the need for modernization and upgradation of existing substations to meet the increasing electricity demand and ensure a reliable power supply. This includes adopting smart grids which can optimize power distribution, reduce the losses, and enable better power quality. Keeping this plan in mind, EPR magazine is conducting an online power talk on next generation power substations. Our distinguished panelists will provide us with an insight on developing trends and technologies in substation designs and operations, such as microgrids, energy storage systems, and sophisticated sensors and monitoring systems, along with the advancements in new and existing substation infrastructure. The distinguished speakers for today's online interaction: Akilur Rahman, Chief Technology Officer from Hitachi Energy; Rajiv Goyal, President from Vivani Consulting Private Limited; Piyush Pandya, Senior Vice President from IndiGrid; and Ajay Tiwari, Associate Vice President for Projects from Jackson Group. Mr. Ajay, I would like to start with you. How can microgrids be integrated into power substations to improve the reliability, efficiency, and resiliency of the grid?
Yeah, basically the integration of that microgrid with substation, right? So microgrid, it's a small source of generations, right? Like solar, wind, battery storage, right? And integration of with the grid, right? So by integrating the grid, the reliability of the powers, by putting the local sources, local generation sources, we can improve the reliability of the power. The local generation sources like solar. Solar is not the 24 into 7. However, we can put the solar, we can put the wind, we can connect with the hydro and battery storage also.
Thank you, Mr. Ajay. Mr. Rajiv, you have been instrumental in substation designing and installations. So, what's your experience and analysis on the integration, on this particular integration to upscale the substation's performance?
Microgrid is something which is uh, injecting the power into the grid from the downstream side, right? So what happens when we transfer power from the upstream? So there are losses and there is a kind of the overloading into the system. When we put the power back into the upstream side, it means that we are nullifying the upstream power flow, means that we are reducing the losses, we are reducing the pressure or the capacity pressure on the our distribution network. So that's the way the microgrid basically helps into the entire system of power distribution.
Thank you so much for sharing your analysis, Mr. Rajiv. Mr. Akhil, how are the advanced communication technologies like IoT and 5G optimize the substation's performance and better the grid stability?
When we see the substation in future, so substations, they are going to embrace a lot of different core technologies, and also not only co-locating, let's say the generation, the conventional generation, but also the renewable power, the solar power, wind power, and also storage, battery energy storage. In future, it can be also the hydrogen, green hydrogen-based fuel cell-based storage. So there will be diverse types of sensors, actuators, controllers, sources. They will be connected in the substation. They have to also communicate. So conventionally with digital substation, with IC61850 communication, but also extending that for the asset performance management, how you can have the additional sensors or get the additional data with the cloud computing, so that you can have more predictability in the substation, the power evacuation, and also doing the predictive reliability centered maintenance. So communication is going to be very important. the conventional, which is deterministic communication, we have ICC 250 based, but also the IoT cloud-based communication where 5G will play an important role. Here we have to just see that the 5G, the new communication technologies, they have to be proven in the power system, in the substation. So that's why we can start using them for the asset performance management. We can start using them for the digital twin, which are the additional layer in the substation operation. So once they are established, it is time tested that they are reliable for the power system application, then we can also use them in the conventional way in the 61850 based communication where we can bring in. So here the goal is that we have to have real-time control, reliable real-time control while the sources of energy, the loads, they are going to be changed. At the same time, they are deterministic. And then we get the real-time information about the asset, about the operation, about the system, and then have the predictive maintenance, prescriptive maintenance, and also integrate technologies like digital twin. Not only just have the augmented reality based application, but also looking at how we can see the substation design, and also at the same time look at the real-time data about the assets, about the transformer, circuit breaker. So that's why communication is going to be playing a big role there. And also very important there is that while this communication, we are bringing in additional communication with 5G technology or maybe even mesh technology, wireless mesh technology within the substation for greater reliability, ensuring that the cybersecurity is ensured and the communication, they are encrypted, they are secured, and any kind of intrusion, any attack happening, we should be able to really identify them immediately so that we can isolate the system from the affected part of the cybersecurity incidents or vulnerability. So technologies are there. We also have applications. We have solutions. We have also demonstrated as Hitachi Energy. We have done this digital substation and also cybersecurity in the communication technology in communication as well as at endpoints. At the same time, we have also developed quantum safe, secure substation. So these technologies are there. It's only a matter of that how we can bring in all these, and also in future the substation will be also modular and scalable. You can start with few let's say in a conventional generation, few generating units, but also you can add solar, you can add renewable, and you can also add more and more. So it will be scalable, not a fixed kind of power evacuation system. Conventionally, it was there because the power was fixed, the units were fixed. But here it will be always changing. Every year you will be adding more and more renewable energy, solar power modules. So how you can ensure that the communication is still stable while it is getting scaled up. So I would say that the technologies are there. There is also competency to implement them and also make them reliable.
Thank you, Mr. Regular. Also, how do you look at the role of regulations and policies pushing this agenda to bring in the digitalization of substations and next generation substations into existence?
When it comes to digitalization, it's not about the regulation or the directives. It'll start mostly with guidelines. I mean, having an installation, having a pilot which is tested, which is proven that yes, this is reliable, then we can bring in the regulation. Of course, regulation will be there on the side of, let's say, grid code and also 62850 based standards, complying them with the core system. So we have to keep the core system, the core substation automation system, the substation automation products, the SCADA, EMS, very, very tightly secured as the core system. And the asset performance management, the digital, the IoT, and also the digital twin, that we have to keep it in another sort of, I would say, a shell little bit decoupled from the core, so that any emerging issues, any new vulnerabilities which is coming because of the IoT, because of the high connectivity, large connectivity with different devices, and also the vulnerability, we should be able to protect our core. Core is basically the substation, which is digital substation, which is the SCADA, with all the primary equipment and also the sensors there, so they can be protected, so that the system is reliable and it doesn't give any surprise in terms of tripping of some base in a substation or maybe substation itself. So we have to follow this in cyber security. We call it defense in depth strategy. That in the defense in depth, it comes from the defense actually army, that you have to create the core and have a shell around it, so that the enemy, here the enemy is basically the cybersecurity vulnerability incidents, virus and attacks. You have to protect them. While the IoT cloud, you can still, can isolate in case of any issue there. If you find, there is attack, there is vulnerability, you should be able to, but the core is still running, so that your substation is running, it is evacuating power, or it is delivering power to the infrastructure. Yeah.
Thank you, Mr. Aklo. Yes, advanced sensors and monitoring systems are going to play a key role in substation management. Mr. Piyush, how do you look at the role of these technologies, and how are the power utility companies adapting them?
I think this is very, very important questions. And when we look into that, probably we have to go one step back. Typically, asset management of substations or transmission was like very conventional kind of a O&M, right? Operation and maintenance people generally used to carry out. Having minimum technology interventions in substations, and most probably on transmission line, driven by more kind of a manual interventions, where patrolling, surveillance, inspections were done on manual basis, recorded, and based on that, certain decision making was done. If we go into the future and the evolvement of the sector as a whole, now India had adopted a one grid principle, and all the zones are connected with one national grid. And emphasis is that we have to serve the grid in most reliable, secure, safe manner at the least cost. So I think this is very challenging one, and there is quite a lot of deep thinking about it, how we could manage both objectives. If we see in the future, the transmission sector is, as we are also countries going from energy transition, from fossil fuel to renewable, more and more renewables are going to add it. And like Power Ministry had a plan of adding 500 gigawatt of renewable connecting to the transmission sector. Similarly, e-mobility, that is also being powered by another electricity mobility. So all this would add a stress to the transmission sector. And that's why it's now a very, very important to have a more secure, more reliable network. And asset management practices also has to be catered to this need. And I think in that case, basically the digitization of all the assets, the data, inspections, records, that will be the foundation block. And on top of it, there will be more kind of AI, ML analytics that will be helpful to convert this data into meaningful informations and decision making. So at IndiGrid, we had, like last year, we had taken a big project of digitizations. We called it a DigiGrid for our, and that is running on a IBM Shift Clouds. And all asset has been digitized, all our substation, transmission towers, solar asset has been digitized. And now we are also having like a analytic tools available with us. So we can get, by click of a mouse, we can get an information which asset are performing how, and we can make certain decisions. Going forward, I think that will be added with a layer of asset performance modules in terms of asset health indexing, in terms of various other solutions, in terms of remote access systems with augmented reality. That will be the future, as well as in terms of solutions like our RAS of us, which also we are working on that. So in nutshell, there is a lot of excitement in this sector, and probably the digital substations, which we are talking since long, will be getting very realistic, practical orientation at the ground level in future.
Thank you, Mr. Piyush, for addressing that. There's one with Mr. Nitin Srivastava, one of our viewers, has a question that he's asking. While we talk about communications, the major losses are happening in the rural areas where there are multiple challenges in terms of communication, especially. So, what are the ways in which technology is helping in reducing the losses, outages, and adding resiliency in the rural areas?
As far as rural losses are concerned, we can have. And if we are talking about the substation technology, definitely there is no way we can reduce the or arrest the power theft. Right? As far as technical losses are concerned, yes, the modern grids now they are working on a system where they like the two power transformers are installed in the substation, and they can sense the loads, the balances, they can balance the power transformers. Probably like we have two transformers of 10 MVA each. So there is a system now that online you can actually, if one transformer is having 8 MVA, the another transformer is having 2 MVA, they can come to somewhere around 5 to 6 MVA each kind of thing. So that's the technical losses can only be addressed in the substation. But as far as the rural losses are concerned, so that's entirely a different subject altogether. I mean, it's not linked to the substation. That's what is my view.
Thank you, Mr. Rajiv, for addressing that. Mr. Akhil, Mr. Piyush, would you like to add your views and your analysis to Mr. Nitin's query?
So here, it's very important that whether the system is already there or maybe we are going to build a new system in the rural areas, we have to carry out simulation studies, which will also indicate whether the feeders, they are radial, and then there are a lot of losses, and then how do you create a mesh network there, power mesh network, so that the power feed can happen from multiple points, and also the losses can be reduced. And at the same time, the reliability can be improved. So when we do this study, even before the lines are laid out, or if they are already there, we can always study them and then augment the system with multiple connections, create a mesh, and then have parallel path for the power flow. First of all, the losses can be reduced. Second, the availability and reliability of power to the consumers can be ensured. So there are different load flow study, short circuit study, reactive power compensation studies we do for planning as well as augmenting the distribution network. That's very important. And today it is very, much there, all these tools. I mean, it has been there. I mean, I remember 30 years back, I was actually doing this kind of study by developing software program and digital simulation we were doing. So today also it is being done. I think many a times the utilities, they don't do that. They just lay some line, and then they are not efficient in terms of losses. As that at the same time, availability, reliability is not there. So, but before even doing that, during the planning stage, this can be always simulated, studied. You can create hundreds, thousands of different scenarios of the load at different point of the day, and then you ensure that the distribution system, the feeders, they are optimally designed. So I think that's one part which the utilities, they should be using this, the system study, the simulation study, digital simulation, load flow studies to do this.
Thank you, Mr. Akhil. Also, there is another question for you. Mr. Prayas Gupta wants to ask is in terms of utilization of OT sensors for predictive maintenance methodology. These are not very costly affairs to utilize in various equipments. So payback is very much difficult to calculate. Hitachi being an OEM of many equipments, what is the view for cost effectiveness of these OT sensors in future to enhance the utilization?
So as you know, these sensors are electronic sensors, and then we are dealing with power where you have the EMI, EMC, high voltage, high current environment, electromagnetic environment. So you can't use the normal sensors which you use in other domains. So it has to be, EMI, EMC tested, and also it has to be very rugged. And at the same time, let's say if we put the sensor in a transformer or circuit breaker, we can't just replace it whenever it fails, because then you have to shut down the feeder and take the transformer out of the circuit, out of the operation or circuit breaker, and then put the sensor again. And then if there is any kind of foreign material or dust or particle going inside while installing the sensor, it can create other type of problem in terms of transformer insulation failure, contamination of oil. So what it means that you have to have sensors which are very rugged. They can work in that environment for let's say 2 years, 3 years without any failure. They have to be that reliable with robust, design, with robust manufacturing. So that is why these sensors are expensive. But we do foresee that in future with economy of scale, because today the utility, they just would like to try sensors in one of the transformers or one of the breakers. So then there is no economy of scale. You cannot reduce the cost because you have to have very few numbers. But as you have more and more usage of these sensors, then the cost can be reduced. And of course, there can be also a non-intrusive kind of sensor, which as Hitachi Energy, we do also use some non-intrusive kind of sensor. Then it can be, it will not affect the core equipment or its performance. So these things will evolve. I think it's all about how the utilities, the industries, they embrace the digitalization and go into fleet mode instead of just one equipment. That is fine as a pilot, as a proof of concept, that is fine. But the proof of value with respect to the cost effectiveness will come when they go for fleet. And definitely there is ROI there once they go for the fleet of transformers, fleet of circuit breakers, and also substation-wide monitoring with sensors. And that can definitely give the ROI, and then the cost can be reduced.
Thank you, Mr. Akhil, for addressing that in detail. Mr. Piyush, my question to you is, how can utility, Mr. Ajay mentioned about integrating renewable energy sources to substations and power grid. So how can utilities effectively integrate them into the power substations to minimize their impact on the grid while improving their efficiency?
Very important aspect, I think, and a lot of work, I think, is going on both on technology front as well as on the asset management practice point of view. So when we had like a scenario where more and more renewable are getting integrated with the national grid, and we know this renewable lacks the inertia support that generally the fossil fuel plants are providing. And there is a challenge of accommodating this, and accordingly, as Mr. Rahman mentioned about a proper study at the planning stage is must, of doing a voltage profile study, short circuit study, load flow study, how you wanted to manage the network with N-1 redundancy criteria. So all these are very, very important at the planning stage. Second aspect is that because of the variability and problem of product predictability, this is going also to be a major issues. And as more and more renewable are getting added, this problem is definitely going to be compounded. And in that space, nowadays, everybody recognize this problem, and there is a plan to have more kind of a storage system also, which is going to be part of solar plus or wind plus hybrid plus battery energy storage or some kind of a pump energy storage. I think with that kind of intervention, it will be help to stabilize the grid and while putting up more of a renewable. From utility perspective, I think there will be a challenge of managing the schedules because if you talk about renewable at megawatt scale, it still be manageable by various load dispatch center. But now as more and more rooftop solar and other microgrid also comes up. Earlier, it was like a clear discrimination between the users and the suppliers. Now this has become very vague. Now it is like a pro users, means somebody is producing also, same person is using also. So in that case, there will be a very, very challenging scenario where how to predict the demand and how to manage the demand, and role of various LDCs will be very important, and to support them in making that decision-making, planning, scheduling. More advanced type of tools, more advanced types of predictable tools will be required. And then along with the digital twins, as we are talking of, I think that will help in future.
Thank you, Mr. Piyush, for sharing your experience and your analysis with us. Mr. Akila, can I please request you to make a closing statement for today's session?
So it was, first of all, thanks to EPR magazine, the team, to come up with this very important topic. I mean, often it is, sort of missed in the discussion of renewable, energy transition, carbon neutral, but substation, and then how it can actually, because as I said, it's the bridge, it's the hub for all these energy and power transition, power flow, evacuation, delivery. So coming up with substation as a topic, and also modernization, which is again very important, that it's not just constructing new substation, but also how we can upgrade it so that it can take more power, it can be more flexible, it can be more smarter, and also it can be more resilient, providing the resiliency to the entire grid. And it was very interesting insights by all the co-panelists, providing different views of substation and what are the requirements, right from communication to the asset, to the sensorization, digitalization, compactness of the substation, and microgrid, how they also can be hosted in the substation, either small or big substation, and how microgrid also plays a major role, and asset health indexing, asset performance management, how they're important to ensure that we have the predictability in the asset operation, and also have the prescriptive based maintenance. Digital twin, how we can use the digital twin for asset performance, operation performance management in real time, but also training the workforce for the future, the new generation of workforce, how they can carry the baton from the old, the retiring workforce, and then getting into the new paradigm of substation, where different technologies will be converging, including digital core, 5G, and also the renewable, the energy transition, which is going to be major, I would say, responsibility of the substation. Interesting insights, and also the questions and the interactions, and I think it was very complementing views by all the co-panelists. And I'm sure audience, they have got good takeaways from this. Of course, there will be definitely questions, and we can definitely answer them in the future session. Because this is one topic, whether it is substation, modernization, or energy transition, carbon neutrality, which is going to be a continuous topic of learning, knowledge sharing for us, more continuous, more frequent, more dynamic than ever, because the transition is happening very fast, and also the technologies are coming very fast, implementation of them, and also the demand for performance, objective performance of the system, of the asset operation, they are also coming. That's why we all have to share knowledge. We have to learn from each other as OEMs, as owners, operators, as technology providers, even the academia. Everybody has to learn and work together to make this vision of our carbon neutral in the country, in the industry, utilities, reality, and also achieve our interim target of 2030 as 500 gigawatts of renewable energy, and then how substation also plays important role in that. So thank you all. Thank you for the EPR team having organized this, and also the co-panelists as well as audience for this interactive session. Thank you.
Now we are almost at the end of the session. I ask Ria to please close today's session.
Thank you, Megha. Thank you, panelists, for exchanging your valuable thoughts on today's topic, Next Generation Power Substations. We hope you have enjoyed it. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Akalur Rahman, Mr. Rajiv Goel, Mr. Piyush Pandya, and Mr. Ajay Tiwari. For viewers who have joined us today, we would like to have your feedback and encourage you to stay connected with us via social media handles. EPR Magazine is also available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. We would also request our viewers to stay tuned for future interactions. With that, today's interaction has now come to a close. Thank you and goodbye.